All right, haven't streamed in a couple days, but time to get right back at it. Maybe we'll see. Here's some grunting. That's my dog. He is a loud French bulldog. And I think I left off getting some basic stuff working on graphics, the graphics screen. So, like drawing lines, and then we figured out the palette colors and stuff like that. I think today what I want to do is go back and refactor some stuff that I'm not particularly enjoying. And stuff like when we redraw the screen here, it's a little hard to see in this, but if I go and actually edit something, there's a flicker. I don't know if that comes through on stream all that well, but there's a flicker when it's redrawn. That's one thing. This whole thing where I'm here and I'm at lines and I'm like, oh, I want to edit, so I go over and it clears the position. That's another thing that I'd like to correct. And then the menu command, which I'm not sure I have in any of these. Maybe this one. Yeah, this one's an actual menu, so it looks like the menu, but it's actually just fake. So see, that's one that I hate. But see how these use these tuples? I realize that I can just make these arrays and just have the first item be the tab name. So I think that's what I will do. We'll make this one kind of broken, but so it'll be like this, and then down here we'd get rid of that, and then this would just be, I've got to fix the cursor. There's a lot of stuff in the edit menu that I need to clean up, or so this would look just like this. Should be an array of arrays. Although I wonder what happens if I just pass that in Python, how it gets interpreted. If we could actually just use multiple arguments, and if that gets switched over when it's brought into IronPython or whatever. So if I did this, which would be a much better simplification, I think. So this would be your, yeah. I'm gonna try that once. It'll break when I run it, but we'll see how it turns out. Argument type exception. So what we want to figure out is what that argument type exception is, and if we can correct it in any given way. I was hoping that, because I think there's a way to pass our variable parameters in Python. Yeah, they're doing it all sorts of ways. So maybe I won't be able to do it that way, but at least I can simplify it down to what I suggested I do here. One thing that kind of stinks about that is that the index gets off then. But that should be okay. And I could offset it myself. Okay. And then there's a bug that I need to fix up as well. And that is when I change from a larger display down to a smaller display, sometimes it works, but sometimes it doesn't. Excuse me. Yeah, so there's an exception gets thrown. And that's because the, I believe what it's trying to do is it's trying to, I've got two threads running. One thread is actually the, is handling the drawing and stuff, and another one's dealing with the program. But all of the stuff that interacts with the display is running the program, so these things don't necessarily run synchronously. So you can have one setting while the other one is adjusting or whatever. So I was thinking about this too, that I might want to try to make it so that all of these actions that we do on the home screen and on the graphics screen and stuff like that, all of this stuff gets run synchronously in the main thread. So these are things that you're dispatching off to the main thread. And what we do is we use, we don't actually use real threading or whatever, but we use, what's it called? Green threading or whatnot, where we break up the actual instruction set into an enumerable using the generator yield keyword in C#. The coroutine way of splitting up stuff. So I have plenty of things I need to clean up, and mostly just because I don't feel like working on the graphic stuff today. I think I will do that. So I also have got, I want to refactor how the input works on these, and because I have the editor that deals with, no, it's the editor in the, is that in the home screen? Deals with things slightly different than other stuff. So I've got a lot of room for improvement here. So I think I am going to, yeah, this overflow and scroll, like there's just a lot of stuff I need to clean up. So I'm just gonna, I'm not sure where I want to start. You know what, I'll get that menu screen thing, or that menu option figured out first. Now what this does do is, I have to remember how to concatenate a list in Python, which I have not done. Prepend list Python. Insert 0x, okay. Which kind of stinks. I wonder if there's a combine to list. Oh, come on, there's got to be like, yeah, a simple way to do this. It's just plus, good. So I should be able to do like this. I don't know if this is... The selection will be there, but it'll be subtract 1 off the... No, it's going to return a 0-based index. Because what it's going to do is it'll break up, like, create new, display, and shut down into those sublists. So now I can add it back in to say it's 1. But actually, I think this should be fine. Okay. So when we receive it here, in the menu screen, what happens is that we, take this as an object array. We get the first item to be the name of the item, and then the options, which is very similar to what we're doing here. It's just this is not what we're doing. T of 1 isn't an object. It would be the rest of T is what we need to actually take. So it's like T skip 1 and then select the rest. That might be all we need to do. Let me try that. Oop. Huh. Name 0 to string. So this doesn't get used again, does it? So why did that break things? Hear that clacking? That's my dog again. He's chomping away on a bone. Let's tab through this and make sure it ends up the way we want it. So we clear that out. Now we've got tabs. Ooh, type of exception. Am I reading that right? It's interesting that it would... Huh. It's throwing an exception, but it's not like actually capturing it. Or is it like it's capturing it in the confines of this here? That's weird. So let's take a look at menu, which is not correct. Oh. And that's because it's actually airing out this menu command gets used internally for other things. So this is getting hit, and then it's... So this actually has to be like this. So that's working. It's just the type. I'm guessing when we call the initial command menu, type error exception quit. So we're not actually ever getting to call the menu there. So what I need to do is go back to the program here and figure out what this exception is actually getting mad about. Which also tells me I need to improve how you can actually debug. Oh, I see. Unsupported type plus for list and array of string. Huh. Oh, I see. And this is happening because on the home, or when we're calling this, this programs right here that gets returned isn't actually a list in Python, and so when you're trying to add them together, they don't work. That's ugly as sin. Well, one thing as you notice here is that I'm not actually using this much to do anything. So I had intended for the OS to be in Python, but in theory I could just move this all into C# and just run it that way, so then I don't have to deal with this issue. Because converting types, this would be, I'm not even sure how I would be able to do this in Python, or in IronPython rather. So it's like, no, I could use this. I wonder if that would work for now. Yeah, I'm not really digging that. I think I might end up having to rethink again how this works, and having some internal programs that we run. You know, the code editor is kind of along that vein, where it should be more of a self-contained unit, as should the kind of the main menu, although it's using the menu feature to run programs and stuff. So I think that that's a worthwhile refactor, would be to do that. Yeah, I think I'm going to do this. So I'm going to rethink how these programs will run for internal read-only ones, and I'm going to get rid of this os.py. In which case I won't need to read resources either. So I can get rid of this thing and just name this why not? Oh, I'm gonna keep that around till I need it though. Okay, so now I need the idea of the computer boots up and it runs a new program like this. But this program assumes that it's an IronPython program, which is not how it should actually be set up. These programs should be able to be pretty much anything. So what we would really do here is say something like, is this actually an awaitable task? It is. something else that's kind of interesting is that each instance runs in its own thread. I don't know if ROM is really the right term for this. I should call it like programs again. I like using the term from the TI-83 calculator, the acronym PRGM. I don't know why we need that. Something different. And what I'm going to do is make an interface called iProgram. Which will just take this. I've got to get that configured to do that automatically. And I'm going to move rename program to be program. Move that up here. That already implements that. Come on, dog. All right, so that is that. And what did I break is the question. So now, this run program really should have be able to be changed. Like, I'm gonna keep it as a hard-coded Python program right now, but theoretically, we could make basic programs or Lua programs or whatever. Python was just the one I wanted to start by supporting. Create Python program. Yeah, that should be fine. And this program registry probably doesn't need to be a separate thing. I can probably move this into the... I should make a... Like I have the home screen, the graphics screen, I should have a system one that kind of has everything in it as well. But we'll keep the refactoring going here. So the program menu is going to have to take on the computer. Component ace. Where is that? We'll start this in its own thread. Okay. So these are system commands, and I have this labeled as program registry. I'm going to rename this one to I don't want it to be called system though. It's not really even a screen. I think I just called it sys in the prototype, or sys API. I think I just call it sys here. Just like sys font. And then rename this to system. I'm actually going to rename this just to home, and this to graphics. And then these ones are all going to get funneled up, I believe, into sys, because that's kind of where it belongs. But for now, we'll leave them. I'm not going to go too far into yak shaving. So we can build, and obviously this is going to fail. Boom. Yeah, not implemented. All right, good. That's where we wanted to be. So now we need to recreate this Python code in here. Then we can dump it. One other thing I realize I need to do is with set foreground, I also need a get foreground, which returns the palette index. And palette. So I need to add those in eventually as well. Because really I shouldn't have to do this reset colors. I think when you start a new program, what I should do is take the current color set and push them onto the push it onto the stack, and then it'll do its own thing, and then when it pops off, it'll reset that, as well as the display resolution. The drawback to that is that a subprogram can't like reset the parent, but maybe that's a good idea. So I just assume that's gonna be the case. So this starts with clearing home, and then it calls get program and runs the menu. Interestingly enough, that means because I'm moving this out of the Python world, I don't necessarily need to expose to Python the get programs or the create or the edit. Which I don't really recall these being part of the TI-83, so I'm going to actually axe these, I think. As part of the API. Anytime you can delete stuff, it's good, right? So we will say, for now, these are gone. Now I still need them internally, but they're not exposed externally to a user. Now just to get this quicker, I'm going to take I'm going to map out the home screen from the computer. Home display program, new line, name equal, no, that's not right. This is down here is what I want. While not shut down. Okay, so I'm just recreating this now. I need to do system.getPrograms. Or that might be in an array already. Then I need to create a menu from them. And this is the structure of that I need to run, which is an array of arrays, but not in Python. This would be just prepend. Should be able to do programs dot prepend. Like that. And same with edit. Alright, that should give me my menu. And then I just need to do this. And then properly go to the correct place. So this would be var tab index equals selections 0 var, and that's not that, it's item 1. Because this is actually a tuple. So option index equals selections item 2. And we say switch tab index case 0. And what we want to do is system run program based off of our progs at index option index like that. Case 1, which is our edit menu, is we want to run our edit program, which was to run system dot, or sorry, not system. It would have been home dot edit. No, it would have been sys. Pass it this, which I'm going to change later. Not run through there, so edit won't run like that. Probably. Or maybe it will, but I'm going to change how it's structured. So this is case 2, which is our create program. I wonder if I could do case 2 when option index equals 0. Can I do that? I think I can. Case 3 when option index equals 0. Case 4, case 3 when option index equals 1. Shut down, it's true. This is run display, which did what? Ran a program. Oh, it actually made a menu. So this is not actually like a program, but it probably should be a separate program that does the display updates. So I could call this like, because I might want to extend this at some point too. Display settings. And I will come back to this at some point, so I'm just going to ignore it for now. But I'll hold on to the code. And so then I just need to do this 310, which was, or no, 30 was run display, 20, which is create program, which was also a just grab the input like this and did it, which I think I will do just like here. I'm going to make this another internal program again, maybe. No, I think I will actually do this like this. Because this is so simple. And I don't see me expanding upon it anytime soon. Oh. And this should then run the name of that program right away, which is not what it did before. All right, so that pretty much sums up everything that I was doing in here, other than some stuff that I need to fix up. Huh. Interesting. Come on, dog, get out from underneath there. You're gonna sit up on me. Come on, buddy. Get out of there. I know you're looking for a comfortable place to lay down. Kids took your bed out. Over there. Come on. Out. Buddy. I know. Okay. So if I've done everything right, this should function. Now display won't. Shutdown will should work. And new should work. Ooh, I don't like how that goes up a layer when you get to more than 10. Oh, why didn't that work? Whoa. Ah. That should be just fine. I'm not sure why this is not. Oh, it actually does. It exits right away. Yeah. Okay. Hi, 5647. It's Python. IronPython, so it's 2.7. Or so it's the older version of Python, but it's Python. These are all, well, I don't know that I've got a really great example of, you know, Python code in here, but this is clearly Python syntax for P in range 16. So, but I'm hoping to support other languages in the future, obviously. And I will refactor to make that so at some point. I think I can run C# if I were to get, if I were to just hook up Roslyn to do C# scripting. I just don't want anything to be compile time. I want it to be dynamic languages, or capable of being dynamic. Okay, so that was that issue. Just being able to restructure the menu command. Come to think of it, I need to fix. Was it this one? Should be like this. I'm not getting rid of the multi anytime soon. Okay. The next thing I wanted to do was, after simplifying that, was to deal with this ever-growing complexity. Well, for one, the flicker that we get, because we have to, you know, clean up the screen and then redraw it every time. Now, there's two ways I can get rid of the flicker. The flicker's happening because, I believe, is because I've got one thread that's actually handling my input where I am... Come on, dog, what are you down there for? I've got one thread that's... Oh, buddy. One thread that's actually doing the updates, and the other one that's doing the rendering. And so these could be caught up at any given time during that speed. What is the best program for Python? PyCharm, I've heard, is really good. I don't actually write a lot of Python. I did in college. I did some at my last, well, my job before this last job. I have tended just to use idle when I've done it, but I've heard really good things about PyCharm, I guess. If that's the, is that the JetBrains one? Pretty much anything JetBrains puts out is pretty top-notch from what I understand. The development tools are really good. I think Visual Studio actually has decent support for Python as well, internally. If you were to, they've got Python tools, and then Visual Studio Code is probably pretty decent as well. So one thought I had with this is that all these commands that go to the home screen, the graphics screen, and the sys one, if I could actually make those run in the main thread to simplify these APIs a little bit. So what that would look like is that during the update loop here, instead of it just being this thing right here, it would actually go through and process a series of, it would process the instructions that are kind of like waiting there to be processed. So something like this, like for each or it would actually, I wonder if it would just run a single instruction forward, is what it might do. So it'd be like something like that. And then how that would get implemented is again like green threading. It's using coroutines or whatnot. So split up the code. But I would have to figure out how I'm going to send data back in and out of it. I do feel like all of this stuff needs to be kind of cleaned up and refactored again, and actually thought through a little bit better. Like the menu and the editor, there's definitely limitations and bugs in them. So like the editor, for instance, once you get beyond so many lines, it doesn't indicate that there's there, and your cursor goes below it, and it's stuck to 10 lines. And obviously, if you were on well, I can't set the resolution now, but if you're on a higher resolution, that doesn't really work for you. So a lot of little stuff like that I don't think is very good. Plus, I've these buffers that I have kind of spread out all over aren't exactly stellar. So I thought in here, run program. Yeah, so like this code editor creates a buffer, and then it gets listened into or whatever. I should just have this into a single stream setup and not split across these two things here. So sys has that on home screen, but it should be just in a single spot. So I think I might rebuild these, leave the ones that they have in place, rebuild them, and then see if I can swap over to them pretty easily. I think, which shouldn't be too difficult, as long as I'm not hosing up the display. But I might save this stuff off real quick. Oh, I should have committed this, then pushed. Okay, so what will we do here? Shutdown's fine, display is fine, system is so I think what I need to do is have the concept of like the home screen, the graphics screen, maintain state, or have state that can be pushed and popped and maintained. and that they're actually just, they don't field algorithms like this. They're more about, because there's a lot in here that's just blah. But if I can separate out and say that, okay, I need to keep track of the state of, well, probably closer to what I had in my original prototype. It's just to treat them almost like a separate thing. Oh yeah, this ugliness too. I need to clean up. Boy. And this probably isn't needed. Okay. Let's start with the home screen, and we'll start where we started before, which is on the clear home. Clear home will set the display mode, and then it will clear the home buffer, and then it will set the cursor position. I wonder if these really should all just be in a single, like, the home screen can exist as a separate thing, but the actual functions, like, should all exist in a class together, maybe, and be as simple as godly possible, so that I don't have to have home graphics. I don't have to do what I did here, which is map them out individually. Now that could be these commands or sys commands that you think could be called this, sys library, the home library, or whatever. Which again, I'm kind of reverting back to the state that I was using in, or the state that I had stuff in FC 360. And there's obviously stuff I don't want available out in the world, so let's build a layer over it. What should we just call this API? Commands, maybe, I don't know. Yeah, there's just so much stuff like packed away in these that it shouldn't be. So I'm working on a fantasy game console, Hexi. That is in very rudimentary stages right now, but it's inspired by, or it's supposed to capture the experience of the TI-83 calculator, but with expanded capabilities like colors and stuff like that. So as you can see, that's broken, and different resolutions and everything, but that's my dog if you can hear that. But if you were to look at the TI-83 calculator and look at the games that were created on it and all of that stuff, That's the experience I'm trying to go for, I guess. Yeah, this is probably a pretty good example of the kind of game that I would have played way back when. Yeah, that's what I'm working on. But instead of using TI Basic in the back, it'll be Python to start, and obviously the engine's being built in C#. But now I'm kind of in this spot where I feel like I need to clean stuff up, but it's there's so much to do. No, just desktop for now, but I mean, I guess with Xamarin I could target Android, iOS at some point in time, but we'll see. And that's all ugly. Sorry, I'm trying to get my bearings on where I'm going to go next with this. I think I wanted to put everything into a single... Put all of these commands into a single structure that is easier to deal with, so I'm not split across different spots. And then home screen and these would be just state containers instead of having state and functionality in them. So just like the display is really just a state container, although it has some operations to interact with it. I could, in theory, separate those out too and make it just a pure state container. And that's kind of what they are. I don't know why that I didn't think about them that way or structured that way. I mean, in theory, that's how I did it in the prototype version I did, which was in the earlier versions of my stream. So, right. So I want to rebuild the home screen and the APIs that go into this stuff here. I should actually name these after where they are in the world. So like sys display. But or where it will be. Okay. Sysrun program. Of course, I could make, instead of making this a interface, I could make this an abstract class and actually just have all of these things be children or in the parent, and that way I don't have to. Actually, that's not a bad idea. I think that's what I'll do. So this will become program abstract class. And I'll make a protected abstract method called execute run, or actually main would be fine, I suppose, as long as it's not static. I suppose I can use that term. In theory, I should be able to pass args to it at some point in time too. just like that. Then we take something like this, and instead of saying executed thread, it would be override main. And this would just go away. Same with the program menu. This would just go away. And then what I can do is say, start moving these options over. So what I'm going to do is add a folder called buffers. And I'm going to make a home buffer, I think. Which will be what the home screen was. Which is effectively a character character screen or whatever. Then there's a graphics buffer, which does the graphics screen. And then there is a, well, the display buffer I'll just move up eventually. So when we run something like clear home will be defined in here as a program that's available to it. I don't think I need to make it public at this point, so we'll just keep it as protected. Clear home. And this is going to need to take a instance of the computer. Yeah, I think like that. So I think what I'm going to try to do with this is, well, that means that all of these will have to pass it to, like I said, I'm going to try to actually run all of the code in the main thread so that I don't ever have to worry about competing, so I have to dispatch that off to the main thread. And this isn't even implemented yet, so I'm not going to worry about that. So right now, clear home is down here, and what it does is it will trigger the computer to run display home, which is an actual command, and then it will clear the home buffer, and then it sets the cursor position internally to the home screen. So in that same vein, this will run sys display home, right? Or no, that's actually on the computer itself for now. Disp home, which sets the active display mode to home. Okay. And these are all of the base sys commands that I need to regenerate here. So I'm just going to copy these into here so I don't have to go back and forth. Okay. GM name. So this has got to be, we've got to copy all of these over. You know, I'm just going to focus on what I need to do here. So I think I might change this so that when I do computer, I can set the active display mode, but instead of setting it to whichever buffer or whatever, active screen, whatever, I'm going to actually just set a mode. And like I said, I think I did this way before. So display mode. This will just be an enum. I want to try something once. Okay, you can't do that. You can specify a type like that, but you can't specify a class for this. Well, maybe you can. But this has to be a struct type. Oh, so it can only be byte, sbyte. Okay. It's just something I was thinking about last night, whether you could type these to be things other than what they are. Speaking of which, and then in our computer, instead of having the maybe this should be on the display itself. Although this is just a display buffer, so it... we can always move it later. I just call that mode. I did. So then I should be able to get rid of this active display mode. So if it's home, then the active one is, for now, it'll be home. Otherwise, it will be graphics, right? And we're going to change all this later, but I want to try to maintain some semblance of compatibility here. And this is a eye display mode. For now. So when program sets runs display home, what it's going to do actually is tell the computer to flip its mode, which it should be able to do without a getter setter or without that. To home or graphics. Not that. This is protected void display graphics, graph. I might move them to the top of the world here in the docs. Okay. So to clear home, what it did is it would run display home, which always switches to the home screen. Then what it did is it cleared the home buffer. So So right along the home screen, we're going to have, for now, buffer. We'll have the option to clear it. And then clear home, reset the cursor position, so the home buffer will maintain the cursor as well, I think, as a position thing, as part of its code, I guess. We will. So think of the home kind of like your console window. It should operate very, very similar to that. So I don't think if we clear it, we would need to, because it should be thought of as a continuous chunk of memory, where when you clear it, the position of the cursor is reset. We're just going to use the point from X and A here to keep track of its position. Actually, maybe we shouldn't. We can have a small class to keep track of it. Oops. Let's call them. It's not going to have a mode like I did with my previous implementation, which was terrible. We'll come back to that. So clear home will do this. Home buffer clear. Well, let's get all of these implemented. Protected. PRGM. So run program took the prgm name. And right now I'm just going to forward these on to where they need to go, which is, I believe this was just sys.run program. And then I'm going to refactor these inside of this world. And I think that's all that run program did, which this was mapped directly. So get key is going to be annoying, but well. I suppose that's an important part of what I need to figure out how to do. Get key returned an integer of the last key pressed since well, whenever. And this is where I really want to get into my refactoring case. So I'm not going to just dispatch that one. I'm going to stub it out for now. And pause waits for the enter key to be pressed, but it actually should, in the TI-83 calculator, the pause will actually cause this little 3 dots in the corner, which is why in the TI-83 calculator you can't actually draw in the very last column. So even though the resolution is 96, let's see if that worked. So even though the resolution here is 96, this last column is kind of reserved for the system, so you only actually get 95 characters or whatever to deal with. And when you did pause, it would cause a little, like I said, a little dancing dot that would kind of show you that, hey, this is paused and waiting for your input, which kind of makes sense because right now when I do run a pause, there's no indicator to me as a user that, hey, this is actually paused at the moment. So I need to think of that. Now, one other thing I want to think about here too is that when in part of this restructuring, and I had forgot about this for a second, I was thinking about the idea of not actually executing these within the thread. So when I run display home right now, when this sets the mode over, this happens immediately within the program's execution thread, which might actually compete with the thread that is actually doing the rendering. So I think my idea here was to do something like this, where I do computer dot, where I would pass along a set of instructions to run. Now I could make this a well, let's just test this out here. So if I were to do computer dot in order to treat this like a, this is going to get the code really ugly, so I might have to have like a different version of display home that's internal connected to this. But in this way I could have a concurrent queue, maybe. Of actions. Called instructions. And we wouldn't necessarily have to have it be thought of this way, because that's going to be really because like this works when it's a single action, but what if it's like the menu, where the menu takes in a bunch of stuff and does some stuff, and then it might actually have to wait till the next input cycle or update cycle to run. So what I could have this be is a function that returns an IEnumerable, or an IEnumerator, I think is what it is. Well, it might be fine to be an IEnumerable. And then when you do this, it would be a yield return. I think. So it would have to be an IEnumerator. Like that, I believe. Oh, you can't actually use this like this, so it would be, I'd have to do something like this. Maybe. I'm just gonna try this out. Hey Scott, how you doing? Yeah, I saw you were streaming. You started about 15 minutes before I did, I think. I'll just call this run. And then we can have it do, whoop, hello. There's a way to make these static now, isn't there? Yeah, buddy. Oh, but then I need access to whatever. Okay. It's interesting that you can do it like this, but you can't do it as an enumerator or whatever. Or this is super ugly, but it technically runs. Yeah, I'm not content with the solution I've been working on, so I'm trying to refactor right now. Well, rewrite is what the technical term. I don't think you refactor unless you have tests. Isn't that the correct way to say it? And this is this is getting a little crazy, but we'll see. These are immediate ones, so they don't actually need to break them up. So this yield is kind of dumb. So I should be able to return. Do I treat my warnings like errors? Probably not. Can't I? That's weird. Why does it think? Why does enumerable.m? No, this is a method. That's why. And that's Is there an easier way to do this? And I thought I could make this an IEnumerable and use the yield. Oh, I can. Okay. Oh, hello. Yeah, I probably don't set them to whatever, but I usually heed them. See, I don't really have many warnings. I wouldn't be against it if I was told I needed to. Well, what the heck? I thought I changed this. Oh, I changed it down here. So now I should just be able to return enumerable.empty for these, right? Oh, there has to be a type. I don't really care. It's like void type. Can you do that? Probably not. I need like a unit type here. Let's make the byte, whatever. Can't I have an untyped and empty enumerable? That'd be just great. I suppose I could just return null in these cases. Wouldn't that be fun? Yeah, it does. I just realized that. Because how can you make an enumerable of no type? You can't. This will be interesting though. So when I do something like so if I operate the way that I'm thinking of here, like clear home runs display home, which technically enqueues an instruction. And then it clears the home buffer, which is a second instruction. So if I put this whole thing in a set of instructions, it's going to queue an instruction. Like, this is going to get really complicated to think about very, very quickly, isn't it? I mean, I suppose I could use the dispatcher.run or whatever, but I think that the dispatcher exists for cross-threading in this context. I'm not sure. So what I'm trying to do, Scott, if you're still there, I don't know that you are, is so when you start a new program, it has to, within the context of this, it has to exist in a different thread, because the Python code will need to run independent of what we're actually rendering. But there's some problems with that in that the code that I'm executing, it like there's just some cross-threaded. So like it'll render during the middle of while the other thing is actually clearing the buffer. So I could solve that by locking all the resources between threads, but then it would just result probably in, like, you know, if this is going to run, it would, I don't know, I think that it's just not going to work quite right. So what I want to do is, just like you would in maybe WPF land, is dispatch all the code like that is run from that thread back to the original thread to be executed, but at a certain point during the update loop. So in here, when MonoGame runs its update loop, what I wanted to do was grab the next instruction or set of instructions or whatever is there, and execute them, so that anytime we're going to actually execute code that's issued by the program thread, that it's actually run during this update cycle and not during this drawing cycle. Do you need mutable state if you're multi-threading? Yeah, I think I do, at least at a root level, because so, like, structurally, I wonder if I've got something I could draw with on here. So what I've got is, like, I've got the display buffer, and then I've got a home buffer, which is basically, like, if you think of it as being like the console mode, and then a graphics buffer, right? And then I've got so let me think about this here. So I've got the main program running, the actual engine running here in a game loop. And then I've got a program running, a Python program running over here in a different loop. I'm not sure I'm whiteboarding this great, but so the engine, this reads the display buffer, and it also will have there's a process that it runs that kind of will copy either that copies the home buffer and the graphics buffer over to the display buffer before the actual like game loop we'll say that runs. So these are definitely, this is a mutable chunk of memory that takes data from, well, I guess it doesn't necessarily need to be mutable. I could recreate it every time and plop it in there and say, here's the new frame. I guess the issue with that is I would be creating 60 frames worth of, and it wouldn't really solve my issue if I did that. But anyway, so the Python program in its thread is mutating the home buffer and the graphics buffer. And so this is where data passes from the program to the, what is essentially, this is more of like your operating system or like your system code, and then this is your program talking to it. It operates through a layer, but I want to have this entire chunk right here run in. Can I send that to back easily enough? To back, there we go. I want this to all run in a single thread, or all the commands that are operated here to modify these or to mutate these run in a single thread. And all this does is dispatch off to it saying, hey, I've got a new thing for you to do. Oh, you know what I'm doing? What I should do is, I don't know why I didn't think of this, is just, and I think I've thought of this, is using the outbox. So instead of actually executing, sorry, I think I just remembered what I was going to do. So instead of having these instructions like this where it's actually running, so this is what I want to have run, is display home. So what I could do is just create a, instead of actually executing display mode, blah, blah, blah here, I can just pass these as messages to a different actor. So treat them like a different thread or whatever. So, or yeah, just use messaging patterns, a mediator between the two. So instead of saying, hey, I'm going to actually give you display mode, I'm going to send you, so if we had like, I don't know, we actually listed these out as instructions. We could have something called, let's see, abstract. Why can't I spell this morning? And actually, these could be records. I don't even need. I forgot we get records now, which is really all I need. Which this doesn't take anything. Many one-line methods. There's not a lot of many one-line. There's actually some of them are very complicated. You know, I am creating garbage with this by not using structs as well. That's one of the things I hate about the fact that these are these are actually records or classes or reference types, that they don't they take up anyways they allocate memory, but I shouldn't really worry about that. That's an optimization I can handle later. So I could have something like this where I still have the instructions. They have structural equality. Yeah, they do. Yeah, they're value types. Is what we're getting at, and immutable by default, which is great. So if I think of an instruction like this as a set of commands, this is kind of like my this would be like my what? I just want to set that explicitly. I know I don't have to. I don't even think that needs to be a concurrent queue or whatever. Now, instead of running display mode home, what I would do here is I would go computer.instructions.queue new instructions.display home, like that. Yep, see ya, Scott. I suppose I could do using static instruction here and making that easier to write off, but so this one would be computer instructions new, and this takes in a PRGM name like that. And the nice thing about records is that it's just so much simpler to write this out. And in fact, I don't even need to do all of this. I can just simplify this whole thing. And so all this is doing is dispatching through that concurrent thing off. Now, these will be a little bit different. Get key, so like ones where it's just simply send me data, that's fine. But there has to be stuff like get key where there's an input and then it's got a kind of a wait and output. That's going to be interesting. So pause and clear home, I think I've got on here now. Good, pause. And in fact, I could probably simplify this too by putting this in queue, encapsulating that so I don't have to type it out every time. Like this. All right. I think I need to run for a bio break quick. I will be right back shortly. I'm back. All right. Yeah, so this goes away. Then if I do using static my D3 instruction, then I can get rid of this. I think that as long as these two don't compete with each other, which they shouldn't. Interesting, I have program down here too. I just realized, but display home. Yeah, okay, perfect. So this should be fine. Now, something I thought of while I was relieving myself is the idea, or is the thought that these things actually need to wait for response. So it's not just a, this isn't just a enqueue, even though that's how it's implemented. It's a queue of instructions. This is kind of like a publish without without a response. But when I run program, this is going to have to be something like request, some other term for the instruction, because there is a response that comes out of this. So run program is PRGM name. And this actually returns void, but it's really returning. It's an action that has to be synchronously awaited. Display home will get published, then you could immediately run another thing. But when you're running program, you're waiting for that program to finish completion before you start on to your next thing. So it starts with a publish of the message, but it has to end in, you know, some sort of response, which is how you do like an async message request. This would be like public void request. So you'd put the instruction on, but then you'd have to wait. You're gonna have to sit here and actually wait while for the response to come to you on another queue or whatnot. Now, this thing is going to wait, but your particular requests could come back in a different order, or they have to come up in like a stacked manner. So this calls a program that then does a bunch of stuff that's going to be waiting for things. This needs to wait for all of those things to complete. So it has to be, it's almost like it has to be, you have to wait for the specific response to that instruction to come back. So what I could do, just for the sake of this, is that there's an instruction in the computer, there's an instruction queue, which is really your instruction buffer. But then I'm going to have some sort of like, you know, well, this is really like your inbox or whatever, or outbox, from depending on which way you're looking at it. But if we had a concurrent dictionary of instruction to some sort of response container, so like we just had an object, and then it could be like instruction output. I don't know. So what this could look like then is so when you publish, it's a straight up instruction in queue, and then it's a fire and forget operation. This one then would say while the computer instruction out does not contain key instructions. So this is where reference types do help me. Then thread, we'll sleep this thread for a bit. So it's milliseconds. So there's what 1,000. It tries to do 60 frames per second. So it'd be 1,000 divided by 60. So we'd want to make maybe a frame. So we'd say like 15, just so we come back, or maybe 17. I don't know. Then what we do is we results, maybe we type it, or no, we'll just set it back. Then we go computer so we grab that out of there, of the instruction out. I don't know, these names are all getting a little wonky, but then we have to remove. Can't you just straight up remove without trying to remove? Delete? Is there a delete? No. Interesting. Okay, we'll try to remove oh, hey, that's kind of cool. Attempts to remove and then returns the value. So I could do this instruction out bar response. Do that. And then this should work because I've just confirmed with this that it contains the key. And then I just return the response here. I know this is a kind of a, or it is a magic number. Maybe I'll just put what I calculated there. So it's 1,000 divided by 60. That's what it's at 16.6. Okay. So that gives us the ability to do this, where it will wait. So get key, which is really nice. We can do request new get key and get key. It's an instruction. I suppose I could theoretically have a response type on some of these instructions that return values, and type it that way. This is another one where it doesn't actually, it waits for it. Okay. This is a push clear home instruction. Okay. So now these instructions get put into that, and the computer will go back to having a tick type operation. These will end up going away. And the tick is going to get the instructions on the queue. Up to so many. So this is how we could technically, in some ways, think of it, limit. Now, interestingly enough, well, anyways, I'm gonna try this. Then it needs to basically process that instruction. So what happens when we get something like a menu command is that it's a single instruction from or it's going to be a single instruction that comes in from the program, but then it actually will execute separate from, it's actually going to, execute separate from what we think of. Now, we could have the menu command be like not really a feature of the home screen, and it could operate under the same, I guess, principles, where it actually runs its main update code in the same thread as Python does, instead of dispatching it like this. So it really, what menu is it's actually a subprogram that you're running that returns a value, which might not be a bad way to think of it. Is think of it like a sysprogram, because it kind of is. So if you did like and then I'd have to figure out how to return a response back from run program, which I've got the concept for now. So menu could be like a special form of run program that runs a specific internal program that deals with. Yeah, I think I like that idea. And then I'll write it by dispatching stuff back to the main thread in the same way that this, other operations are run. So let me think about this in terms of the program menu. Then the program menu is actually there's going to be a bootstrapper that grabs the list of programs, and then it's going to run the menu program. So really, once this is done running the menu program, then it would close out the entire thing. I gotta think about how this is all going to play out together. If I get rid of the menu command as a specific, I mean, it will still be like an API command, but it's not going to be run in the same basic instruction set as what we do with these other things. So, interesting. But anyways, so in this part, it's going to be computer.tick. And tick will go and read the instruction set, and then it has to process those. Although menu might be fine. I don't know. We'll have to. Okay, so these are all going to end up moving on here. And actually, this could just be a switch here, right? We've got an instruction. We know we have it. Then we would case type each of them. Case instruction dot clear home, for instance. Or we had what? Case instruction dot display home. Which we really don't care about. It's just a signal. We don't care about any content in it. Case instruction dot display graph. And these can be just written right here. So it's like display mode equals home mode. This is graph mode. What else we got? Run program. This is something we do care about. So currently what this involves is running system.run program which would block our so we need to set this up as a continuation. So we need to effectively do the same thing, but I'm going to copy this in here. Just set it up this way. I might get rid of these sub things like sys here eventually. It's just kind of like unnecessary splitting up of stuff. And I'm going to get rid of that for now. And that should be a capital PRGM. I wonder if the refactoring is good enough. Yes, it is. Sweet. So this gets the task, and then what I want to do is just like I did up here, is to do a continue with. Oh. Come on. And what I do is I set the instruction out for this instruction, which is RP. Do null, a null object. Oh. That just takes one. So what that will do is communicate back to the waiting thread, which is in program right here. That's actually run in the separate thread, which is looking for this instruction to get that instruction back and then complete its operation. Actually, I just realized something. I can reduce this further because this is a... So I can say, well, this does not try to remove. I can just do this, right? No. I could do this just while true, and then just continue to try to remove it and then break from the loop with the response return, right? But I'll just leave it for now. Okay, so that will run a program. Clear home just will run for now, home.clear home, which later will be changed. Oh yeah, it was going to be home buffer dot clear, but it also runs, sets the display mode equal to home mode. That. just to reduce some interpret, is that correct? Yeah. Okay. So what other ones do I have stored in here? Pause and get key. So pause will, and then there's case instruction, get key. So what I could, something I hadn't thought of here is that I should really make it so that I can return a value out of when I actually execute a program. I'm going to think about that later. But so let's think about pause for a second. So what pause does is it sits there and it will eventually have a spinner. Now that spinner needs to actually execute as part of this instruction set right here. But nothing else, it needs to be a blocking set too. So it's very much like a run program that has a very specific task to it. So I could think of this as like a pause program. Let me just try modeling it that way once. Just like I would do with menu, effectively. Try running it like this. I don't even think that's right, but the naming here. It's a program. But it's got more like capability than it does than other programs do, so maybe this doesn't really belong here. Might have to think this one out a bit. So it has to run in its own thread, or it has to run at least its own green thread. And because otherwise what will happen is that if it puppy if it doesn't run like that, then it'll block this thread. Now a running program doesn't block this thread because it will actually run a separate thread entirely that will begin. Yeah, so that should be fine. So with get pause, with a pause, the instructions are going to keep. Maybe this could be thought of as like a recursive instruction. So what pause does is it checks to say, in this frame, did I press a button? Did I press enter? And then it just pushes itself on to the queue. So it's like pause comes in. The first thing it would have to do is immediately publish another instruction to say wait for enter. Multi-threaded programming is difficult. Or I just run it like this. Just realizing too, there's another way I could model this out instruction. Is it could say if there's a value there and the instruction pointer is pointed to me, and just make this a stack, or not a stack, a single value. But I don't know, that might get a little confusing. Not that this isn't super confusing to begin with, so... Okay, so none of these can actually block. But maybe I have some internal commands that we don't, or instructions that we don't issue out to the rest of the world. So instead of this being like continue with, like this, this within its own thread run could actually send back an exit, like an exit code. So think of it this way: we run, execute, we're done. Then we have an instruction called and it takes an object called a return, which is an instruction. It can't just take the return value though. It has to actually take, so I know what instruction to send. So the idea here is that in order for this to finish up this execute runs in the Python program here. And when this is all done, what it will do is it will run a computer dot instruction in dot enqueue new return instruction with eventually potentially a particular value, but for now it'd be null. Then when return is found here, it would have to it would set that value in the some instruction or whatever. But the thing is it has to know how to release that. It would have to, without doing this thing where I'm like correlating, it would have to know to release this instruction without this here. So if we did that, then what happens is your program, which is running, I'm going to put an underscore in front of these just so that we know that they're not supposed to go out to the outside world. In fact, maybe I should do that here as well. Heck. That means I'd have to think of a different way to finish out this request. So this is going to sit here and loop, and there's no indicator to it that it can continue on to the next step. So it's going to sit and block, and it's just going to keep polling until it gets a release to keep going. Now that release to keep going doesn't necessarily need to be a response in its... I'm just thinking about this now. I might be overthinking this a lot, but I think this will come out better in the end. I just need to think about how this is actually gonna... So this is kind of like simulating my CPU. So it's like there's like an interrupt table, right? And when you do a run program, that runs an interrupt for a while. That doesn't return immediately, but it actually hands code over to the operating system, or this, to say actually run this program. Now at some point in time that completes execution, and then it's running a return code, which is going to be an instruction. Right. And the return code needs to somehow return control back to a different thread. So this does stuff, then runs a program, it executes it. I suppose that this program could be put, the original program could be put on a stack, so we actually keep track of them like we would with a function pointer. Or not a function pointer, like an instruction pointer, or like a, yeah. So how did we have this? A private stack. Program. So we are going to, you could turn this into a signal actually, so we don't have to do it like this. But we do prog dot. I know this got messy last time, but I don't know if it has to be messy by itself. So you boot, you put this, the main root menu on, and then it's running. The shutdown flag, we'll just take that off for now. So we push that on, and then we execute it. So that's running in its own thread. Now it's going to run some other program right here. And we push that onto the stack as well. And then it gets executed, which should run it. Which means every program, when it's done, whether it be this one, or this one, it has to do a return instruction, which is really like, you think about it, an exit at that point. So if we just make this like that, we put this on here. Actually, it should be called exit probably, but now maybe it shouldn't even have to call it in the main. It'll call it, it could call it early, I suppose. But it could just be part of this right here, where main gets executed and then exit is called automatically. Or perhaps it keeps its own state like that. Oh, I did actually have a return on here. So for now, we'll just have these all have to return a value. And then I'll fix this later. And this isn't actually, I'm just going to delete this until I actually implement it. So now return is a signal or an instruction. So this is a, this doesn't actually have to sit there and wait for it. It can just operate and run, and it's not going to be on a callback when you call tick. So what this will do is it's going to interpret the instruction, return instruction, which should have an uppercase value. I've got to get used to naming it like this for records. Would be to take the program stack and pop it. Gives us the current program back. And now we can tell it to kind of release its hold. Can't that push on there? Python program is a program. Oh. Derp. I need to fix that at some point. So it's kind of like it needs to release it. So it's like I don't know, join with at return values value. Resume maybe? I don't know. Or I suppose if just to keep things, yeah, I don't know. So resume would set this we'll say that. So we'd set that as waiting to false. So when we request, we would start with is waiting true. We'd enqueue the instruction, and then we'd say while is waiting. We sleep, we're done. We get our response out, which is actually a copy of, we'll just take a reference to, well, now that shouldn't be, I mean, just in terms of within this thread, resume gets called, the response is set to the value, it gets shot out here, back to whatever's waiting for it, so it comes out the response track on these things here. Yeah, I mean, these things work together, so they probably should be closer to each other and separate from. This feels really, really crazy. All of this connection stuff, all of this. Now, return, I just realized, doesn't need to actually be called there. And in fact, maybe shouldn't be like this, because main gets called and could return the object directly. And then I do this. Oops. And then I do publish. Or no, this would happen after return. So I would do the resume here. Or no. Yeah, I would just do... I need to pass the resume to some other thing, so I would be calling publish new a return instruction with the return value here. And I'm going to call this response or respond. Or maybe I call begin request complete request. Like that. Why is this way the heck up here? Okay, so then programs like this need to be augmented to return an object, which in cases will return null. For now, I'm later, aren't I? There we go. And Python program for now will return null. There we go. Okay, so what that does is then it issues a command called, or an instruction called return. That instruction gets hit by the computer, which then gets the return instruction. It pops the program, the currently executing program, off the stack. Sorry, it's not the one that's on the stack that needs to be completed. It's the one that is next on the stack. So this does a pop, and then if program stack.any, then it will do gets the top program and completes the request that it's had out. So instead of calling this request, okay. I know that's all very crazy, but I'm going to move this up to the top so it's very clear that these work together. So run program and then return. gonna go with like that. So this is like a call and a return. So this one will push onto the stack something new. Internally, the act of calling this means that it's put in a waiting state. Then when return happens, it takes the program off the stack and then it completes the request. So anytime we send out a blocking request, this will just hang waiting right here. Okay. That doesn't happen in these ones. It will happen in these ones. So pause, for instance, is basically a type of program that needs to run, but it's like an internal program versus what run program does. I think I'm going to do some of these cleanups that I need to do and then call it a day and let me think about this for a little bit. And I'm probably not going to push this stuff till I'm good and ready. Well, I should probably, I suppose. I want to keep all of this there for now. I'm just going to replace every instance with this. Compound requests. Get key doesn't really belong there. And this will get changed then to this, and I should be able to disp graph. What's wrong with that? Oh, I suppose I could put an H on the end of it. And this would be run program. I think I've got get key mapped. Although it doesn't do anything. These aren't set up. And maybe I won't actually have these. Well, I think set and get resolution might be ones, but and I think I moved clear home over, although it's not quite there yet in terms of what it needs to actually accomplish. And neither is clear draw, but so I might move those ones back. So display home's gone. Display graph gets called at the beginning of all of these. So this is dot mode graphs. And we'll just copy that in every place that it needs to for now. that. This is like tick, so this should actually technically still exist, but probably up here. And maybe not forever. Set ground, foreground, and background. These ones should be these shouldn't be here, but I don't know where to put them yet. Maybe on the because the display buffer isn't that. I mean, technically you could have, I suppose, a set foreground or set background different depending on which display mode you're in, and they don't necessarily need to cross over to each other. Because what if you wanted a home mode that followed a certain set of colors, and then you go to, you know, whatever. So maybe set foreground and background are unique to whichever buffer you're actually targeting versus being a unique one. The other thing I could do them is treat them as part of the display, but as like a read only. You know what? That's what I'm going to do for now. Just like the palette. But this really, like I said, doesn't make a whole lot of sense because it doesn't make a whole lot of sense because you actually write to the internal buffers and stuff like that. So it actually more belongs, is contextual to whatever you're doing. So like on the home screen, there should have a background and a foreground color that's set. And then these should be contextual to it. So I can move these back here. For now. And then have the same thing in the graphics screen. Now, maybe that'll be kind of annoying because then if you're switching and you want to maintain the same colors across home and graph screen, you have to know to push them the same. So, or that when you switch over to graphics screen, your colors might be different. But for now, I think this is fine. Oh, you know what though? The set foreground and set background, they can't exist separately. They'd have to still exist on the main display. So maybe that's a whole bust. Yeah, let's just move them to the display and call it good there. For now. And we'll remap them out later. Maybe I'll pull the palette out into its own object again and I could do that. So this would go to the computer display FG. Computer display background. And on the graphics screen, we're fine. Display needs to have a set foreground, set background. Again, these do not belong here whatsoever. Oh, these will be removed. clear draw. Goes to the computer display for background. And you know what? I mean, maybe the fact that the home screen and all these, maybe these all should be wrapped up into the display object as just various sets of buffers that I need to be modifying. Computer display. I just wanted to move them off there so I can clean this up a little bit, or just remove some of the mental overhead of what I'm doing. In the computer object, because there's a bit of complexity here in terms of you know, really boot then at this point in time is a specific program that targets not a Python program but an internal program. I really should have a way to make this uniform. But and this isn't currently getting used, but it probably should. Or I could just make these static on a abstraction that represents the disk. And pull this over from there. Make this called just this read program. What you doing, buddy? It's my dog again. So I'd read that program in and then do that. So that takes some of that complexity out of this and puts it in a place it should go. But then I can also take this thing and start to clean this up too. So like just change this to be disk.read program name. I could call this like write program. Go back to here and figure out what's broken. So this would be read program. Of name. And this should just be called at the beginning of write. On the disk. And I can get rid of that and call, just make this be able to do that. And then this listing would be another one. So we've just abstracted those things out into something that's easier to kind of deal with in places. Now I've got an error down here. Oh, this is called completed code. I know I said I gotta go here soon, but I wanted to just get that cleaned up. Set myself up for a good spot for program. Sorry. Computer. Oh, well, that's weird. Why did it want to? So some of these I will want to probably get it down to a single line like this, or like these ones, or one or two lines without, you know, that, or just put them down here. Now I bet if I run this, this is going to be all hosed up. Yeah. Surprisingly, some of this actually works. I'm actually really surprised. All right. So if we pop, why did that pop? Interesting. When I ran it again. Kind of ugly, but whatever. So shutdown doesn't work anymore, but it does take me out of because shutdown doesn't set the flag. So what happens when I run shutdown on my main program menu is that it sets such shutdown to true, exits return nulls, and then it just ends. So really, as we could say, is if program stack there's not any programs to run at this point, then we're done. Shutdown is true, and we return. Otherwise, we pop it and continue executing. Like I said, I'm a little surprised that it would ever... Maybe there's like a fraction of a second where... Yeah, there's got to be like a fraction of a second or something where it's... where that stack gets completed, so... Oh, you know why, I bet. It's because this pause isn't implemented. Pause is sitting there waiting for return. Well, no, it's using the old pause. Yeah, so there's... It's probably just in the way that these things are interacting with each other, maybe. So we run exit. The program stack has the program's menu on it, which we pop, and then we don't have any, so we shut down. But it should have that colors on it. So what happens when I exit colors? Or why is the original program not... So is this getting called twice is the question. Or why does this not have the color menu on there? Which it should have had from here. Oh, because it's still running the run program from the old world. So this needs to be set up to do the new world run, which is actually just that. Like I said, the other thing I need to do is figure out how to push and pop. Probably push and pop colors based on, so that I don't have to do the reset like that. Okay, that fixes that. And presumably then, if I run shut down, it shuts down now. Okay. I'm going to go and break for lunch and take care of my daughter quick. Instructions. Q. All right, I'm going to call it good for now. Thanks for watching.